Hello everyone, hope you're doing well. So today we have a really beautiful question and we're going to investigate how we can actually use inequalities to solve some Diophantine equations. Now, in most cases when you just see a Diophantine, you're like, maybe we can factorize it, maybe we can like reduce it mod n, maybe we can find out certain residues. But so in certain cases there are actually certain inequalities, and sometimes the intuition for that, the hint for that is kind of embedded in the problem itself. The problem kind of like gives you a hint. If you want to solve me, you kind of have to use an inequality. And yeah, it just reduces your cases significantly and makes your life a lot easier. So yeah, let's see how we can deal with that. This is problem number 1 from the Chilean National Math Olympiad in 2011. And in this video, we're going to be looking at how we can use inequalities to solve Diophantine equations. And after that, a neat factorization result. I wouldn't really call it a result, more like a technique, I would say, to factorize certain things, factorize Diophantines. And after that, book suggestions for National Olympiads, and at the end, a similar Macharjik problem.
This video is sponsored by Chinta.com. Since 2010, Chinta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
So what have they told us? So the goal is to find A, B, C belong to natural numbers such that it satisfies the inequality and this equation, right? Now, A less than equal to B less than equal to C, and this is less than equal to 1, greater than equal to 1. Now this is kind of irrelevant because A, B and C are natural numbers. So of course it's greater than 1, right? Greater than equal to 1. Essentially A is less than equal to B less than equal to C. And when I write that, I can write 1 by A greater than equal to 1 by B greater than equal to 1 by C. This is obviously because A, B, C are all natural numbers. They're greater than 0. Great, now that's perfect. Now, what have they given us, right? So 1 by A plus 1 by B plus 1 by C is 3 by 4. So, well, if let's say they had given us, maybe let's try investigate like an easier example. If they had given us this, right? They had given us this. What would you have done? You would have just let 1 by A is equal to X, 1 by B would have put Y, and 1 by C would have put Z. So x plus y plus z is equal to 5, and then this is pretty much solvable, right? It's extremely solvable, like standard equation. And standard methods of solving. But what makes it a little bit trickier is you have this fraction over here, and that fraction it's not necessarily the easiest thing to do now. So what do? In the question you have this inequality. They're hinting you to use an inequality, so might as well use it in the solution, right? So if you just observe, if a is greater than equal to 5, let's just take that assumption. Let's just kind of like maybe try to limit our cases in a way. And they've given us A less than equal to B less than equal to C. So 1 by C less than equal to 1 by B less than equal to 1 by A less than equal to 1 by 5. Right? If A is greater than equal to 5, that means 1 by A is less than equal to 1 by 5. A is positive, mind you. It's a natural number. Okay, great. So 1 by A plus 1 by B plus 1 by C will be less than equal to 1 by 5 plus 1 by 5 plus 1 by 5. What's the maximum that these three quantities, 1 by A, 1 by B, and 1 by C, can take is like 1 by 5, right? It's greater than or equal to. So 1 by A plus 1 by B plus 1 by C is less than equal to 3 by 5. So 1 by A plus 1 by B plus 1 by C is less than or equal to 0.6. But in the question, they've given us that 1 by A plus 1 by B plus 1 by C needs to be equal to 3 by 4, which is actually equal to 0.75. So actually see, for A is greater than equal to 5. Just keep in mind, just for A greater than equal to 5, 1 by A plus 1 by B plus 1 by C is never greater than 0.60. So it may be 0.5, 0.4, 0.35, 0.25, 0.2, something like that, but it will never ever exceed 0.60. So it will never reach 0.75. So therefore, no solutions for A greater than equal to 5. And this is actually great because it just really limits our cases. Now A is a natural number, right? So A can either be 1, 2, 3 and 4. And let's just formulate 4 cases and figure out how it works. So case 1, A is equal to 1. In that case, 1 by A plus 1 by B plus 1 by C is 3 by 4. So 1 plus 1 by B plus 1 by C is 3 by 4. And 1 by B plus 1 by C is negative 1 by 4, which by the looks of it pretty much says it all. Of course, it cannot happen. B and C are positive quantities. So 1 by B plus 1 by C are also positive quantities, and sum of two positive quantities can never be a negative quantity. So obviously no solutions for this case. Moving on to case number 2, maybe let's analyze A is equal to 4, right? So 1 by 4 plus 1 by b plus 1 by c is equal to 1 by 2. So 1 by b plus 1 by c is equal to 1 by, sorry, this is actually 3 by 4. Yeah, so now it's 1 by 2. Okay, great. And again, if I just use inequality, there are a lot of ways to solve this, There's another way, I'll discuss it for the last case. But let's maybe just again use inequalities over here. So if b is greater than or equal to 5, then what happens? Then you know that 1 by c is less than or equal to 1 by b less than or equal to 1 by 5, right? Again, just literally losing the same idea. So 1 by b plus 1 by c less than or equal to 1 by 5 plus 1 by 5, right? You know the drill. So 1 by b plus 1 by c is less than or equal to 2 by 5. Or in other words, 1 by b plus 1 by c is less than or equal to 0.4. But in the question, they're given us that 1 by b plus 1 by c needs to equal to 1 by 2, which is 0.5. So again, no solutions obviously, because 1 by b plus 1 by c can never ever ever exceed 0.40 for b greater than or equal to 5, right? So b greater than or equal to 5, it has no solution. So b can be 1, 2, 3 and 4. But here we are analyzing a is equal to 4, and in the question they've given us that a is less than or equal to b, less than or equal to c. This was the condition given in the question. So b can only be these 4 quantities, but since a is 4, b can only be 4. So a4, b4, that leaves us with 1 by b plus 1 by c is equal to 1 by 2. I'll just plug in b is equal to 4 over here. So I'll get 1 by c as 1 by 4, or c is equal to 4. So a is equal to b is equal to c is equal to 4. So 4, 4, 4, the triplet is a valid solution. Right? So we have the first solution already. Okay, that's great. So let's move on to case number 3. Case number 3 is a is equal to 3, right? So 1 by 3 plus 1 by b plus 1 by c is 3 by 4. So 1 by b plus 1 by c is 3 by 4 minus 1 by 3, and 1 by b plus 1 by c is by 12, 9 minus 4. So 1 by b plus 1 by c is 5 by 12. Again, using the same idea, if b is greater than or equal to 5, that means that 1 by c less than or equal to 1 by b less than or equal to 1 by 5, right? So 1 by b plus 1 by c is less than or equal to 2 by 5. In other words, 1 by b plus 1 by c is less than or equal to 0.4. But here we want 1 by b plus 1 by c to be equal to 5 by 12, which is roughly equal to actually 0.41. Yeah, it's quite a minute difference. So again, no solutions for b greater than or equal to 5, right? Same argument, precisely the same. So no solutions for b greater than 5. It will never reach 0.41 basically. So what can b be? B can only be 1, 2, 3 and 4, but here we are considering a is equal to 3. So these two are obviously eliminated. So we only need to check for b is equal to 3 and b is equal to 4. So if I put b, so we had 1 by b plus 1 by c is equal to 5 by 12, right? If I plug in b is equal to 4 over here, I'll get 1 by 4 plus 1 by c is 5 by 12. 1 by 4 is nothing but 3 by 12. So 1 by c is 2 by 12, so c is 6, right? So a is equal to 3, b is equal to 4, c is equal to 6. In other words, 3, 4, 6 is a valid solution. If I plug in b is equal to 3, what will we get? I'll get 1 by 3 plus 1 by c is equal to 5 by 12. 1 by 3 is really nothing but 4 by 12. So 1 by c, I'll get 1 by 12, or I'll get c is equal to 12. So I'll get a is equal to 3, b is equal to 3, and c is equal to 12. So 3, 3, 12 is also a solution. So till now we have 3 solutions, I believe, right? First we found 4, 4, 4 from case number 2. And in case number 3 we have 2 solutions, 3, 3, 12. And we had 3, 4, 6. Right? So let's move on to our fourth and final case. Case 4, fourth and final case, which is a is equal to 2. So we analyze a is equal to 1, we moved on to a is 4, then a is 3, and then lastly a is 2. So 1 by 2 plus 1 by b plus 1 by c is 3 by 4. 1 by 2 is nothing but 2 by 4. So 1 by b plus 1 by c plus 2 by 4 is equal to 3 by 4. In other words, 1 by b plus 1 by c is nothing but 1 by 4. You can use inequalities, but it's kind of boring. It can get boring. So maybe let's just use another technique to solve this, right? So you can just simplify this as b plus c is equal to 1 by 4. Standard factorization actually. And it has a name. I'll tell it towards the end. So you get 4b plus 4c is bc. Okay. After this, 4b minus bc is equal to negative 4c. I'm just going to rearrange the terms. Take b common, I'll get 4 minus c is equal to negative 4c. If I just add 16 on both sides, the idea is to create this 4 minus c on the other side as well somehow. That's kind of the idea. So b times 4 minus c is equal to 4 times 4 minus c. And there we go. It's been created. So b times 4 minus c minus 4 times 4 minus c is equal to negative 16. Just bring that to the left hand side and factorizing, I'll get b minus 4 times 4 minus c is equal to negative 16. So b minus 4 times c minus 4 is equal to 16. And yeah, just two pairs, two conditions like ab is equal to 16, standard solutions. You have seen this many times before, I guess. So this can either be 16 times 1, this can either be 8 times 2, or this can be 4 times 4. And since b is less than or equal to c, b will always assume the smaller quantity, right? So b minus 4 will be 1 and c minus 4 will be 16. So that gives us b is equal to 5 and c is equal to 20. You will have b minus 4 is equal to 2, c minus 4 is equal to 8. You will get b is equal to 6, c is equal to 12. Another solution, you will get b minus 4 is equal to 4, c minus 4 is equal to 4. You will get b is 8 and c is 8. So here we have three solutions indeed. You have 2, 5, 20. You have 2, 6, 12. And at the end, you have 2, 8, 8. So three solutions here. 3 we had found early, therefore 6 solutions in total. And yes, this is a pretty cool problem, and this technique that I actually used over here. I did not use inequalities for the last case, which would get boring. I didn't use inequalities for this one. It's actually like a famous factorization technique. It's called SFFT. It's just called Simon's favorite factoring trick, and it's used a lot. It's used a lot on a lot of exams, National Olympiads, AMC, AIME. It's a really great thing to know, and it's quite intuitive. It's not something that you really need to kind of like force it into your brain. It's quite intuitive. But regardless, I hope you really enjoyed that. I hope like you got the idea of using inequalities maybe to solve certain Diophantines. And yeah, at the end, maybe like a little bit of kind of intro to SFFT. We'll obviously explore that in future videos as well. Right, so certain book suggestions for National Math Olympiads. You have Elementary Number 3 by David Burton, Principles and Techniques in Combinatorics, Problem Solving Strategies by Arthur Angel, Functional Equations by Venkatachala, Problems in Plane Geometry by Sharikin, and Elementary Number Theory by Sierpinski. Okay, awesome. So a similar but challenging problem. Again, kind of similar actually. Find all x, y, z, which are natural numbers, so this satisfies this given equation. Again, we try to use some inequalities, and I actually want to give another one. So if you're able to solve this, might as well try this, right? 1 by a plus 2 by b plus 3 by c plus 4 by d is equal to 9 by 16. It's really very interesting. A, b, c, d, 1, 2, 3, 4 is equal to 3 by 4 whole squared. It's kind of like a problem I came up with. But yeah, try to use inequalities. That's the thing. Try to use inequalities to solve this. And if you make any progress on it, or if you're able to solve it, please let me know in the comment section and I'll help you out. Until then, I'll see you in the next video. Thank you very much. Bye-bye.
Chinta programs are designed for students who are passionate about mathematics. And they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Chinta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Chinta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit chinta.com.